Welcome back to the Deep Dive. This deep dive is proudly presented by Bluewater Auto Restoration, your trusted partner in keeping your vehicle running and looking its best. We're in week 40 of the 2025 Bluewater Auto Restoration Deep Dive series. And as you know, we drop new deep dives every Saturday morning. Our mission, well, it's really to bring you the most important nuggets of knowledge, keep you well informed and ready for pretty much anything the road or life throws at you. Today, we're flipping the switch on a topic that, well, it literally lights up our lives on the road. We're talking about the incredibly fascinating and, often debated world of automotive headlights. Specifically, we're tackling the big showdown, LED versus halogen headlights. Okay, let's unpack this, because as our deep dive into the source material really shows, understanding your car's illumination isn't just about seeing, it's about safety, it's about driving comfort, and maybe even the personality of your vehicle.
Indeed. Yeah, our goal today really is to cut through all that marketing noise and just give you a solid, comprehensive understanding of these two dominant lighting technologies. We'll explore their fundamental differences, their unique strengths and weaknesses, and what each choice really means for your vehicle and maybe more importantly for your daily driving experience. We're aiming for those aha moments, right?
Yeah.
The ones that clarify not just what they are, but why their distinctions matter to you. And it's fascinating, isn't it, how these seemingly small tech shifts can lead to major implications for visibility, for costs, and even how cars are designed.
All right, let's dim the fancy lights for just a moment and maybe journey back a bit. Back to where much of modern automotive lighting really took hold. We're talking about the classic, right? The
Yeah.
type many of us grew up with, and let's be honest, probably still have lighting our way in our daily drivers. So
Yeah.
for anyone wondering, what exactly is a halogen headlight bulb? What's that familiar glow all about, at its very core?
It's a fantastic place to start. Because a halogen bulb, despite its age, it's still quite a marvel of engineering in its own way. It's a really sophisticated evolution of the very first electric light bulbs. At its heart, it's composed of three key things. You've got a tightly coiled tungsten filament. That's the bit that actually glows. And that's all encased within a sealed, heat-resistant quartz glass envelope. And here's the really clever part. Inside that quartz bulb, there's a small, very precise amount of a halogen gas, usually iodine or bromine. The magic happens when electric current passes through that tungsten filament, just like a traditional light bulb. This current heats the filament up to an incredibly high temperature, and that causes it to incandescent. That's just the technical term for glowing brightly from intense heat. Now, in a regular old incandescent bulb, that tungsten would slowly evaporate, right? You blacken the glass, and eventually the filament would just break. But this is where the halogen gas comes in. It's kind of like the unsung hero here. It facilitates what's known as the halogen cycle.
The halogen cycle, that sounds kind of high-tech. How does this gas actually, perform its magic?
It's almost like this tiny perpetual motion machine inside the bulb, really. As tungsten atoms evaporate from the hot filament, they don't just drift away and stick to the glass. Instead, they react with the halogen gas. This forms a gaseous tungsten halogen compound. Then, when this compound drifts back and comes into contact with the superhot filament again, the intense heat breaks it down, and boom, it redeposits the tungsten right back onto the filament. The halogen gas is then freed up to go repeat the cycle. So this continuous recycling process, it dramatically prolongs the bulb's lifespan compared to standard incandescent bulbs, often like 2 to 3 times longer. And maybe more importantly, it allows the filament to operate at much higher temperatures without burning out too quickly, which is precisely what gives halogen bulbs their increased brightness and whiter light compared to their older, dimmer cousins. It's really just some ingenious, elegant engineering.
So it's definitely not just some relic of the past then. It's a technology that's genuinely evolved and, well, it continues to be practical, right? You still see them everywhere.
Absolutely. They've been the industry standard for such a long time that their prevalence is just undeniable. Even today, many vehicles rolling right off the assembly line, including incredibly popular models from manufacturers like Toyota, Honda, Ford, Chevrolet, they still come factory equipped with halogen lights. They have lit up our roads for decades, proving their reliability and effectiveness. And their continued use really speaks volumes about their enduring value, especially when you think about initial manufacturing costs for the automakers. Hashtag 1.2 advantages of halogen headlights.
Okay, so given all the buzz around newer lighting tech, it's easy to just assume newer always means better, right? But halogens have been with us for decades. What are some of the maybe unexpected strengths or just the stubbornly practical reasons they're still so prevalent today? Are we maybe underestimating their appeal?
That's a perfect way to frame it, yeah. Well, LEDs definitely grab the headlines Halogens offer several really compelling practical advantages that keep them firmly in the market. The first, and you could argue the most significant for many drivers, is their lower upfront cost. Halogen bulbs are simply far less expensive to buy and replace. Our research shows a pair of replacement bulbs typically ranges, $35 to maybe $100, with an average price right around $50. So that makes them an incredibly budget-friendly option, not just when you buy the car, but for ongoing maintenance over its life. For many people, that accessibility is just huge. And beyond the price, there's a distinct characteristic in their light quality and weather penetration. Halogen bulbs emit that warmer, yellowish light, usually around 3000K to 4300K on the color temperature scale. Now, while some might see this as less modern than the bright white of LEDs, a lot of drivers actually prefer this warmer tone. They find it may be less harsh, a bit gentler on the eyes of oncoming traffic, which is a significant point of courtesy, right? But maybe more critically, this yellowish light often seems to offer superior penetration in bad weather conditions. Think heavy rain, dense fog, even light snow. That warmer wavelength can sometimes cut through moisture and atmospheric particles more effectively. It potentially reduces that glare that brighter white lights can create, maybe improving visibility when you really need it most. It's a surprising benefit that's often overlooked.
That makes a lot of sense, especially for drivers who, frequently encounter bad weather. I remember trying to change a halogen bulb once in my old car in a dark parking lot. Let's just say it was less easy DIY job and more, well, frustrating. So when you say easy installation, are we talking like swap out a battery easy or call your mechanic in tears easy?
Hopefully closer to the swap out a battery end of the spectrum for most. Easy installation is genuinely a major plus for halogens. For many, many vehicle models, changing a halogen bulb is a pretty straightforward DIY task. It doesn't usually require specialized tools or a deep dive into automotive electronics. You often just twist, pull, unplug, and plug in the new one. It's pretty simple. And this ease contributes directly to their lower overall replacement costs, because you might avoid paying a mechanic's labor charge. It's definitely a confidence booster for the average car owner to be able to handle this basic maintenance themselves. And their wide compatibility is another huge advantage. Because this technology has been around for so long, and its design uses that traditional bulb and reflector setup, well, halogen bulbs are compatible with a vast range of vehicles. Their design traditionally uses those larger, robust reflector-style housings that are just standard across countless makes and models, especially older ones. This means finding a replacement bulb is rarely ever an issue, no matter what older car you might be driving. And finally, there's an interesting, maybe somewhat counterintuitive, heat benefit in cold climates. We often talk about the high heat emission of halogens as a drawback, right? It's wasted energy. It can degrade components over time. However, this intense heat, which can exceed 150 degrees Celsius, that's over 300 Fahrenheit at the bulb's surface, can actually be quite helpful in very cold, snowy, or icy conditions. It really helps to melt snow and ice accumulation right on the headlight housing itself. This prevents your lights from getting obscured by frost or slush, ensuring you maintain visibility and safety, which is especially important for drivers in, say, northern regions or mountainous areas. So that waste heat actually finds a kind of practical purpose in certain environments.
So we've charted the reliable, warm glow of halogens, the workhorse of the automotive world for so long. But as the sun kind of sets on that era for many manufacturers, a new light has really dawned. It's fundamentally changing how we see and how we are seen on the road. So how do these modern LED headlights completely rewrite the rule book on automotive illumination? It's a fundamentally different approach, isn't it?
It is indeed. It's a complete paradigm shift, really. Moving from a thermal process, heating something up, to an electronic one. LED stands for light-emitting diode, and as the name implies, it's a solid-state semiconductor device. It emits light when electrical current passes through it. There's no filament to heat up, no gas to cycle like in a halogen. The core component of an LED headlight system typically includes several tiny LED chips. Those are the actual light sources. Then you have a sophisticated heatsink to manage the thermal output. We'll talk more about that. There's also an electronic driver to regulate the electrical current, and often a precisely engineered lens or reflector to shape and direct the light. The way an LED works is through this process called electroluminescence. Think of it like an incredibly tiny, perfectly orchestrated dance within the chip. You'd send an electric current through this special semiconductor material, and in there, electrons, almost like tiny dancers, they pair up with holes, which are basically just empty spots where an electron should be. And when they connect, when they complete that tiny circuit, bang, energy is released. But not primarily as heat, but directly as light, those photons we see. This direct conversion of electrical energy into light is just far more efficient than the thermal process of incandescence used by halogens. It's solid-state technology too. That means there are no fragile filaments to break, no gases to leak, which contributes to many of its significant advantages. It's essentially a microchip that glows.
And we are seeing these everywhere now, aren't we? It feels like it's becoming the standard for many premium vehicles, maybe even moving beyond just being an upgrade option. It's almost the expected level of illumination now. It signals a certain modernity too, doesn't it?
Absolutely. If you look at the automotive landscape today, LED lights are rapidly becoming the norm, not the exception.
Yeah.
They're commonly found as standard factory equipment in modern cars from luxury brands like Audi, BMW, Mercedes-Benz. Yes. But also from innovative companies like Tesla and increasingly on more mainstream models too. This widespread adoption really underscores their role in not just vastly improved visibility and energy efficiency, but also in defining the aesthetic and the technological prowess of contemporary vehicle design. They're quickly becoming the expectation, shaping how we perceive new cars. Hashtag TechTag 2.2 advantages of LED headlights.
Okay, so beyond just being new and modern, what makes LEDs such an appealing and, well, increasingly popular choice for both drivers and automakers? What are the real tangible benefits that truly stand out when we, switch them on?
The benefits are quite profound, really. It's a significant leap forward in automotive lighting tech. The first, and maybe most impactful for the planet and your vehicle systems, is their high energy efficiency. This is a dramatic difference compared to halogens. LEDs are remarkably efficient. They convert over 80% of the electrical power they consume directly into light, which means less than 10% of that energy is wasted as heat. Compare that to halogens.
Which was, what, 90% heat?
Exactly. 90% heat, only 10% light. It's a massive difference. This efficiency not only conserves energy, leading to maybe a lighter load on your car's alternator, but it also translates to a smaller environmental footprint overall. And directly stemming from that efficiency is a significantly longer lifespan. This is a major, major selling point for LEDs. While traditional halogen bulbs typically last, 500 and maybe 1,000 hours, LED